application of law
So your voice.
in register circuits.
सर वॉल्यूम क्लियर नहीं है.
Hello.
It's
Hello. Hello.
results in
हेलो.
सर को आवाज नहीं जा रहा.
हाँ
algebraic
वॉल्यूम क्लियर है.
equation.
Yes, sir. Hello. Yes, sir.
सर आवाज नहीं आ रही आपकी.
Resistor along with capacitor or inductor. Then, okay, we apply a Kirchhoff law. The application.
सर आवाज क्लियर नहीं आ रही. आवाज नहीं आ रही ना सही.
हम लोग के भी नहीं जा रही.
सर आवाज ठीक नहीं आ रही. काफी ऐसे आ रही है. दूर से बोल रहे हैं माइक से लग रहा है.
Am I audible now?
Yes, sir.
यस सर.
Okay. So application of Kirchhoff law in resistive circuits results in algebraic equation, and application of Kirchhoff's law in RC and LC circuits results in differential equations. Okay. So we are going to discuss now first order differential equation of first order circuits. So in this first order circuits, the first thing is source free circuit. Okay, a circuit which does not have a source. So for example, if I take source free RC circuit, source free RC circuit. Now, what do you mean by source free RC circuit? For example, we have a capacitor and a resistance, okay, connected or end to end. Now, what I'm doing now, I am charging this capacitor, say with some voltage V naught. I have some source, okay, of V naught, and I'm charging this capacitor. So what will happen? This capacitor will charge up to the voltage of this source. So now once this capacitor is charged up to V naught, because it's parallelly connected. So once this capacitor is charged, now what I do, I remove this source. Okay. So now it become a source free circuit. Okay. So this is your source free RC circuit. Okay. Now what will happen? Now this capacitor will become discharged, will discharge. Okay. So when it will discharge, okay, a current will flow here through this capacitor. Okay. So suppose this is a node A, and this current will flow through resistance. This current is IR. So these currents both current should be same. Okay. So now capacitor will get discharged. So the initial voltage of capacitor is V naught. Okay. So at t is equal to 0, okay, VC naught equals to V naught. Now what will happen? Once capacitor will discharge, so it potential will decrease. At a certain time, it will have a voltage, say VT. Now VCT or VT. Okay. Now I want to calculate this voltage. Okay. Once I have removed the source, after time t, what is the voltage across this capacitor? So that I'm going to calculate now. So suppose now I can write my IC is equals to IR in the circuit. Okay. When I remove the source, now IC is the current coming through a capacitor, and I know the current through capacitor is given by CB dV by dt. Now since this is a discharging current, okay, discharging current means now voltage is decreasing. Voltage is decreasing. So so this is a negative. Initial voltage is high, later final voltage is low because the voltage is getting decreased. Okay, so I need to put one minus sign here. This become my IR. Okay, now just solve this one. Calculate the V as a function of t. Okay, so what I can write now? I can write now IR I can write V upon R. Okay, V at a time t, V upon R. Okay, so now if I want dV by V, I can write this is minus 1 upon RC dt. Okay, now if I solve this one, if I solve this one, this will give me what? Integration dV upon V, okay, minus 1 upon RC dt. Okay, and this will give me ln W equals to minus 1 upon RC t, and of course there will be some constant, say C. Now at t is equal to 0, my voltage is V naught. Okay, so if I put t is equal to 0, my C will be equals to ln upon ln V naught. Now if I put this value here, this gives me ln of V upon V naught equals to minus 1 upon RC t upon minus 1 upon RC. And if I further solve this one, this gives me V equals to V at a time t is equals to V naught minus t upon RC. Okay, so this is my required equation. So at time t, if I know what is the initial voltage across the capacitor, okay, I can calculate what is the potential of capacitor. This is the capacitor voltage, okay, at after time t. This equation is very useful. So now once I know what is the voltage at time t, I can of course calculate what is the current at time t, and the current at time t will be simply V naught upon R E minus t upon RC. Okay, and I can also calculate power. Power t will be simply I square R. Okay, or I not V. You can write IT and VT. Okay, so if I put this will give me what? This will give me V naught square upon what should I write? IT is what? IT is your V naught R e power minus t upon RC, and VT is your V naught e power minus t upon RC, and this can be written as V naught square R e power minus 2t upon RC. So this is the required power at time t. Now now what is happening? Your capacitor is getting discharged. Okay, when capacitor is discharged, current is flowing through resistance. That means now the resistor is absorbing the power. Okay, so we can calculate how much. So initially the capacitor has a voltage V naught. Okay, so initially the capacitor has at time t is equal to 0, capacitor has energy V naught is equal to 0, half C V naught square. Okay, now it's this energy is decreasing with time because capacitor is getting discharged, so this voltage is changing, so energy is decreasing. Now how much energy is absorbed by resistance? Okay, and in time t, so we can calculate energy absorbed or loss by resistance okay, in time t can be calculated. I know the power pt dt. Okay, now you know the power pt. Okay, so I can write v naught square r, okay, e power minus 2t upon rc dt. So let me solve it further. So I can erase this one, this part. Okay, so if I erase this part, I can calculate the energy absorbed. Okay, so this is v naught square upon r. If I integrate this one, this will give me what, e power minus 2t upon rc divided by 2 upon rc. Okay, that is rc upon 2, r cancel, and this is e power minus 2t, and the limit is 0 to t. Okay, 0 to t. And if I solve it further, this will give me w, okay, equals to half c v naught square. Okay, and the minus will, of course, minus will come here, minus sign will come because when we integrate this one, so I can change the limit. Okay, so I can put 0 first. This is a minus, so I'm changing the limit, so I'm putting 0 1. This will be 1. Okay, e power minus 2t upon rc. Okay, so this is the required expression for power absorbed, energy absorbed by resistance. Okay, after time t, once you have removed the source. Now if I put t tends to t equals to infinite, so what will get? I'll get half c v naught square. I put t infinite here, this term will become 0, so I get half c v square. So whatever the initial energy was stored in the capacitor, that all energy will be decay. Okay, that all energy will be absorbed or lost in the resistance, because the current is flowing, the capacitor is getting discharged. Okay, so this was your source free RC circuit. Now how to deal circuits? This was simple circuit. Okay, there was simple R and C, and we have been given the initial voltage V naught, so we can calculate the voltage at any time t, later time t, across the capacitor. We can also calculate how much power is absorbed by resistance and in time t. Now whenever you have been given this kind of circuit, source free RC circuit, source free RC circuit का मतलब है you will be given a circuit where initially there will be voltage source, and they will remove this voltage source, and after that the voltage of capacitor will decay. Okay, so this is kind of like a transient analysis. They will ask you at a later time what is the voltage across the capacitor. So in order to deal this kind of questions, okay, what should we do? So the key points, and what I'm telling here, that is a general thing. You can apply any RC circuit. Okay, so the key notes, key points to deal this kind of circuits. So you should know that any time voltage Vt is V naught, okay, e power minus t upon Rc. Okay, now Rc is generally your tau. Okay, the time constant of RC circuit. RC tau is generally time constant of RC circuit. That means if you want to calculate voltage, you should know initial voltage. So number one, you should know, okay, V at t is equals to 0. You should know this value in a circuit. You should try to find out this value. And next you have to calculate, number 2 point, you need to calculate time constant tau. Okay, and tau is your nothing RC, and RC is nothing, RC is R equivalent. Okay, So in order to calculate R equivalent, you need to find R Thevenin across C. Okay. So suppose you have any capacitors given, you just need to remove this capacitor and you need to find what is the equivalent capacitor across the resistance. Once you know, if you know the capacitance value, immediately you can find what is tau. Okay. So let me write here what is R equivalent. Okay. R equivalent is the total resistance across capacitor C, across capacitor C. So let me demonstrate this by a problem. So suppose I have been given one question. So I have been given one circuit. This is 5 ohm resistance. Okay. Then you have 0.1 farad. Okay. And then you have here 8 ohm resistance. Okay. Then you have a 12 ohm resistance. Okay. So, and the voltage, you need to calculate what is the voltage VC at time t. And in the question they are giving you V naught. This is given V naught, that is V at t is equal to 0 is already given to you 15 volts. Okay. So you're asking what is the VC at a later time t. Okay. And he asking also what is your Vx here. So we need to find VC, Vx, and they're also asking Ix. Ix means current flowing through this resistance. Okay, at t greater than 0. So I'm repeating again the questions. You have a capacitor which is initially charged up to 15 volt. Okay, and suddenly you remove this source. Okay, now this capacitor will get discharged. Okay, and I need to find a VC, Vx, and t and Ix at later time t times t which is greater than 0. Okay, so what should I do? So simply I need to calculate first. I already know V naught. So one point already clear. The second point, I need to calculate R tau, and tau is what? You're nothing, your RC, R equivalent C. So I need to find only C. I know already 0.1 farad. So I need to calculate only R equivalent. Okay. So what is the R equivalent across this capacitor? So you can see this 8 and 12. If I remove this one, if I open this one, so what is the total resistance across this capacitor? So 8 and 12 are in series, so you can 20 and 5. So 20 and 5 are parallel. Okay, so I can write R equivalent. R equivalent is nothing, 5 ohm parallel to 8 plus 12. Okay, that is 5. 8 plus 12 is 20. So this will become 5 into 20 upon 25. This 1, this become 5, this is 4. So this is your 4 ohm resistance. R equivalent is 4 ohm resistance. Okay. So I can easily calculate what is the VC at later time t. So V naught I already know 15. Then E power t upon RC. Okay. So RC is tau. So my tau is R equivalent is 4 and C is 0.1 farad. So this become 0.4 second because time 0.4 second. So I can write this is 15 e power minus 0.4 0 point is t upon 0.4, okay, second, and this 15 e power 4.10, what I can write, 10 by 4, it is 5 by 2, okay, that's 5 by 2 vt, okay, this is volt, so this is my vc t at some later time t. So hope you understand. So this you can write 2.5. Okay. So I already know now this VC. Okay. Now I need to find what is Vx. So let me now calculate the Vx. Vx is nothing. You know this KVL, this potential will be divided between these two resistances. So if I want to calculate, okay, Vx is the voltage across 12 ohm. Simply I can write, okay, this voltage total Vc. So Vc is 15 e power minus 2.5 t, okay, and the resistance is 12. And doing voltage division, and total resistance is 20. Okay, so this become 5, 3, this become 4, this become 3. So the Vx can be written as 9, okay, e power minus 2.5 t at t greater than 0 time. Similarly, you can calculate your Ix also. Okay, if you want Ix, okay, so Ix will be simply divided by Vx by R. So you can calculate the Ix. Ix will be simply 9 e power minus 2.5 t divided by 12. Okay, so my Ix will be what, 3 by 4 e power minus 2.5 t. So this way I can calculate my Ix.
Sir, Vx 12 by 20 means
हाँ,
the voltage
अभी
division.
ये सारा वोल्टेज इसके ऊपर ही तो आ रहा है,
Yes, sir. Yes,
ये
sir.
पैरेलल में इसके बराबर तो है, तो
Yes,
कितना
sir.
डिवाइड होगा, वोल्टेज डिवीजन आई एम अप्लाइंग.
Okay, sir.
Okay, now let me solve one more problem. So suppose now so this was a simple question where you have been given V naught. Okay, let me solve one more question. Okay, so now you have a battery, 20 volt battery. Okay, and here you have 3 ohm resistance. Okay, and across which you have here 9 ohm resistance. Then you have here a 1 ohm resistance. Okay, and then they have given you 2 millifarad capacitance. Okay, so they say here one switch is there. Okay, and that switch is get opened at t is equals to 0 time. Okay, so before t less than 0. Okay, so when t was less than 0, this switch was closed. So at t less than 0, what happens, this switch was closed and now you're opening. So let me calculate when it was closed, what is the voltage across this capacitor. So when once I close this one initially before time t is equal to 0. Okay, so this switch was closed initially. So what is the voltage here? So you can calculate voltage here, make it open. So if you make it open here, okay, so no current will flow here. You want to calculate voltage VC here at t is equal to 0 time VC. Okay, if you can VC, so open this one, so no current will flow here. So whatever voltage comes here, that will be your VC, isn't it? Okay, so my VC will be what? My VC will be at 20. This become 20 divided by 12 into 9. So this become 3. This become 4. Okay, and this become 5. So I have 15 volt. Okay, so once this is in the beginning, it is a 50 volts. Now at t is equal to 0, the switch is opened. Switch is opened. So once you open the switch, that means you have removed the circuit. Okay, once you remove the switch, that means you open this circuit. Now you have disconnected this part of the circuit. Now we have only this circuit. Now this is source free circuit. So this voltage is given so that you can calculate what is the voltage at t is equal to 0. So whatever voltage we have calculated here, okay, this is equal to what? This is VC at t is equal to 0, because at t is equal to 0 they are opening. So just before t is equal to 0, okay, VC at just before t is equal to 0, that is 0 minus time, is equal to VC at t is equal to 0, and this is just equal to VC at t just after 0 plus time. So I told you the capacitor voltage cannot change suddenly. So whatever voltage you have before opening this switch, that will be maintained at t is equal to 0, and just after t is equal to time, little bit time 0 plus. Okay, so now
So
I
it
know what
means
is
it will be 15 volt
yeah, yes, 15
before
volts.
and after.
सर प्लीज एक
Yeah,
बार स्विच ओपन
yes.
है तो स्विच ओपन है तो 1 मिनट रिपीट कर दो स्विच
जैसे आप
ओपन है तो
पहले आपका स्विच क्लोज था, ओके,
यस
क्लोज करके मैंने वोल्टेज निकाला, यहाँ पे कितना आया 15 वोल्ट.
दैट इज 15 वोल्ट.
Now I have just opened this circuit. Okay, so just after the time, okay, suddenly voltage will not decay. So just after that, at time t0, earlier it was before t is equal to 0, this was VC 15. At t is equal to 0 also it will be remain same, and t is equal to 0 plus time it will be remain same. Okay, that means it will not change suddenly. So now this will become your initial voltage once you have removed the circuit and you open this circuit. Okay, now you have this voltage, initial voltage. Okay, so I told you that there are 2 points, key points. First thing, you need to calculate VC at t is equal to 0, and this is already given in this question, we have calculated. Okay, and the next thing is simply you need to calculate R equivalent. Once you know the R equivalent, you can find tau, which is R equivalent C. Okay, C is already given 2 millifarad. Now you just need to find the final circuit. Final circuit में निकालना है क्योंकि वो तो हमने हटा दिया. We need to make source free circuit. Okay, so this equation what we are applying, V is equal to V naught e power t by RC, that is only applicable to source free circuit. So now I need to calculate what is R equivalent, and R equivalent is what is R equivalent? R equivalent is nothing. Okay, these two sources are in series 10 ohm, so R equivalent is just 10 ohm. Okay, so if you calculate tau will be 2 millifarad into 10 ohm. Okay, that will become 20 into 10 raised to power minus 3 seconds, or you can say 20 milliseconds. 20 milliseconds. So I can write my
तो
equation
ओपन
now.
करने के बाद 9 और 1 से ही करंट जाएगा ना?
हाँ,
ओपन होने के
ओपन करने
बाद
के बाद दोनों सीरीज में तो है.
Oh,
If you open this one here, they both are in series. Okay, because they are not connected end to end because there's an open gate here. Okay, open है तो now you want V at later time t. Okay, and t is greater than 0, so you have VT 15 e power. Okay, let me check answer also one time whether I'm doing a mistake or not. Okay, so this I'm calculating. Just give me 1 minute for this question is correct. Okay, so this is 20. This is 20 or 200. C is what? C is 20 millifarad. Okay, so you had a mistake. This is 20 millifarad. Okay, so 20 millifarad into C. C is 20 millifarad, and time is t. Okay, so this becomes 200 milliseconds. Okay, so that is, or you can write this is a 0.2 second. This is a 0.2 second. Okay, the question may here it is given 20. I have written 2. Okay, this is become now 2.2 seconds. So I can write e power minus t upon tau is 0.2 second. Okay, so again I get vt equals to 1510, so e power minus 5t volts. So this is my vt at time t, at a time t. Okay, and I can also, if you know the v, you can also calculate the energy. Okay, what is the energy, initial energy, what is the final energy, how much energy is lost after time t, all these things you can calculate. Okay, in this question. Okay, so let me solve one more problem. Okay, now you people need to solve this problem along with me, and you have to tell me what should I do here. So I'm giving you a source plus minus 24 volt. Okay, and then you have 6 ohm. Okay, this is open, this is your 1/6 farad. Okay, then you have 12 ohm, and then you have this is 4 ohm resistance. Okay, you need to calculate Vt at later time t is equals to 0. Please calculate.
Sir, initially the time to close है ना?
Initially close है. So this is getting open at t is equal to 0. So we are opening it at t is equal to 0. So initially it is closed. Okay. So can you tell me what is the initial voltage? So when this closed, so this was closed initially. Okay, so this is closed. Now what I need, I want voltage across this one. Okay, so these two resistors are in series. Okay, so whatever voltage will come across this, that will be my voltage. So I can write this is a plus minus 24 volt, 6 ohm resistance. Okay, here I have a capacitance. So and here I have 4 into 12. So 4 into 12, how much you will get? 4 into 12 upon 16. So 1, 4, this becomes 3. Okay. So this becomes 3 ohm. Okay. Now this voltage is getting divided. If I make it open, I want open circuit voltage. Okay. So this getting divided between these two. So I need across 3 ohm. So my VC will be at t is equal to 0, just before 0 time. Okay, when I just before 0 time. Okay, will be what? 24 divided by 9 into 3. So this is 3, this will become 8. Okay, so VC at t before t is equal to 0 is 8 volts. Okay, so I can say this will be, this voltage will be remain at t is equal to 0 and this voltage will be same at t is equal to 0 plus 1 time. Okay, so I know what is my VC. Okay, so 8 volt ही आ रहा सबका? All of you getting 8 volts?
Yes.
8 volts. Okay, now at t is equal to 0, you are removing this circuit, you're disconnecting this circuit. Okay, so now you need to find out what is the R equivalent. You need to open this one and you need to find out R equivalent. What is the value of this one? F, this is 1/6 farad. Okay, so if I want now R equivalent is simply just now calculated 3 ohm. Okay, and tau will be R equivalent C, that is 1/6 into 3, that is 1/2, 0.5 second or 1/2 seconds. Okay, so I can write my equation. V equals to V naught e power minus t upon RC. So V at time t will be 8 minus 2 t. Okay, volts. Okay, so this is correct. So now similarly, this was source free RC circuit. Okay, now if there is a source free RL circuit, the same thing, same method. Okay, we can do it for source free RL circuit also. Okay, so let it be complete for source free RL circuit. So source free RL circuit. Okay, RL circuit. Source free RL circuit means you have a inductor L connected to a resistance R. Okay, so at t is equal to 0, what I'm doing, I am putting here removing the source. Okay, so if you're removing source, the current will flow like this. Okay, and when its current will flow like this, it will go like this, plus minus R. Okay, so if I apply KVL in this loop, suppose this is a VL, VL, okay, across this one, and this is VR. So what will happen if I apply, if I remove source? So you know, conductor voltage always comes up opposite polarity. So if you write now KVL here, you can write VL, okay, plus VR equals to 0. Okay, and you know what is VL? What is VL? How can I write we can L di upon dt? Just one, give me 1 minute. So if I write now for source free RL circuit, okay, so what is the
Sir,
voltage?
L and R are parallel, so voltage will be same or different?
Just our voltage will be same. Okay, but then if I apply KVL, okay, KVL also should give me same value, na? So if I write this VL, okay, so that will give me L di by dt, okay, plus VR, okay, that is IR equals to 0. And if you solve this one again,
minus L di by dt होगा.
hmm?
Minus L di by dt होना चाहिए.
वो माइनस मैंने यहाँ कंसिडर कर लिया, इधर कर दिया मैंने. ठीक है. So now if I write this minus कर लो, okay, then you put here plus minus. Okay, so then this will be minus. Okay, so if you put minus again, you have to put one more minus, so finally it will come like this only. Okay, so L di upon dt. Okay, so di upon I. Okay, what will become? बिग इंडक्टेंस क्या करता है, हमेशा अपोज करता है, वोल्टेज चेंज का अपोज करता है, अपोज करके अपना साइन बदलता है. सो एल डी अपॉन डी टी माइनस आई आर, सो डी आई विल बी योर आई, ओके, माइनस आर अपॉन एल डी टी. ओके, सो इफ आई इंटीग्रेट दिस वन, दिस विल गिव मी ln I minus R upon L T. Okay, some constants is C. Now at t is equals to 0, if I assume there is a current I is equal to I naught, okay, so this will give me ln I upon I naught, okay, minus RL by T. And if I solve this one, I equals to I naught, okay, I equals to I naught e power minus T upon L by R, okay, L by R or R by L. What is there? R by L, okay. So L by R को मैं क्या लिख रहा हूँ? L by R को मैं लिख रहा हूँ time constant of the circuit, okay. L by R is a time constant of the circuit. So I can now write this equation: I equals to I naught, okay, minus T upon tau. So tau is again the constant for me, okay. This is a time constant of LR circuit. So this is a time constant and this is given by L by R, okay. So again this equation become important in source free RL circuit. You should know I naught and you should know time constant. Time constant method is same, okay. Time constant method is same. Time constant method means, okay, you need to find now R equivalent, okay. So R equivalent is equal to resistance across L, resistance across L, okay. So again 2 points you need to find: first I naught and second you need to find tau, which is R equivalent, okay, L by R equivalent. This time L by R equivalent. If you know these things, you can find anytime T what is the current in flowing in inductor, okay. So let me show this one by one example. Now यहाँ पे मैं जो भी solve कर रहा हूँ, okay, finally I will come to a general equation. अभी मैंने निकाला कि सोर्स फ्री सर्किट है. अब बाद में मैं जो नेक्स्ट करूंगा उसमें मैं बोल दूंगा कि सोर्स फ्री सर्किट नहीं है, कोई कांस्टेंट सोर्स है, हमेशा अवेलेबल है, ओके, इन द सर्किट में. तो वहां से जो इक्वेशन बन के आएगी वो जनरल इक्वेशन होगी, वो इन पे भी एप्लीकेबल होगी. और जहां भी आपको सर्किट में आरसी मिल जाए और एलआर मिल जाए, दैट विल बी योर जनरल इक्वेशन. आंख बंद करके उसको अप्लाई कर लेना, ओके. कोई भी डिफरेंशियल इक्वेशन हो उसको अप्लाई कर देना, you will get the answer, okay. So I will show you some problems which came in exam also. So now let me give you one problem. I have this plus minus 40 volts, okay. Now you have a 2 ohm resistance. This is, here we have one key which we are opening at t is equal to 0. This is 12 ohm, okay. Then we have this 4 ohm resistance. Then we have this 16 ohm resistance, okay. And then you have this inductor L equals to 2 Henry, okay. So I need to find I, okay, I t at a later time t, which is greater than 0. So same, first I need to calculate what? I need to calculate what is I naught. First point to calculate I naught. I naught is what? I naught is I at t is equal to 0. So initially this was close. So let me make it close. So I'm making it close, okay. So what is the current here? So DC, for DC source, inductor behaves like a, for DC source,
Short circuit.
short circuit, okay. So I am making this as a short circuit. So once I make this short circuit, this resistance also becomes short, isn't it? Resistance इसका क्रॉस में जोड़ दिया तो जो करंट आएगा वो यहाँ तो जाएगा नहीं, सारा यहाँ जाएगा. That means now this resistance also become useless. Okay, so now this is my circuit, and I want to find what is current is flowing here. That will be current at t is equal to 0. Okay, so current I at t less than 0 time. Okay, or you can say current I at t is equals to 0 minus time. I need to calculate. So I can apply simply current division here. Okay, first I need to calculate total current IT. So IT will be what? IT will be simply these two resistors are in parallel and this series. So total resistance will become 40 volts divided by 2 ohm plus 12 and 4 are parallel. 12 and 4 are parallel. Okay, 12 and 4 are parallel. So this gives me 42 plus 12 into 4 upon 16. This is 1, this become 4, this become 1, this become 3, this become 40 upon 5, that is 8 ampere total current, isn't it? Now this total current I need to divide in 12 and 4.
सर 12 को 4 पैरेलल कैसे देगा सर?
पहले देखो कैसे देखेंगे, पैरेलल ही और कैसे है, एंड टू एंड कनेक्शन है दोनों में, एंड टू एंड
ओह
कनेक्शन है
यस 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 यस
okay, so end to end connection hai. So you can now your total current 8 ampere, so this 8 ampere current is coming here. Okay, now just do it, apply current division. Okay, current division, if you apply current division, I want current in 4 ohm, that will be my I at t less than 0 time. Okay, so this is equals to total current, opposite resistance, total resistance 1 2 6. Okay, so 6 ampere is the current what I have. I t less than 0 equals to I t is equals to 0 and I t 0 plus, that is equals to 6 ampere.
सर 8 एम्पियर करंट भी तो वही था, IT लेस देन 0।
कौन सा वाला?
8 एम्पियर।
हाँ 8 एम्पियर टोटल करंट था ना, फिर हमको तो इसमें इस सर्किट में इस इंडक्टर में चाहिए ना जो शॉर्ट सर्किट हो गया. Okay, so now you have 6 ampere. Okay, you can collect back. Now you are already opening this circuit, so I don't need this, require this circuit. Okay, and here there was 16 ohm resistance. कितना 16 था ना, 16 12 4 16. Okay, here 16 ohm resistance and here you need to put an inductor. इंडक्टर का वैल्यू कितना है? इंडक्टर का वैल्यू है 2 हेनरी. ओके, सो आई नीड आर इक्विवेलेंट. ओके, तो आर इक्विवेलेंट कितना हो जाएगा? आर इक्विवेलेंट मींस दीस टू आर इन सीरीज, तो ये इसके पैरेलल में है, तो आर इक्विवेलेंट कितना हो जाएगा? 4 plus 12 and that is parallel to 16 ohm. Okay, so 16 parallel to 16, so this become my 8 ohm. Okay, so tau will be simply L upon R. L is 2 Henry, R is equivalent is 8 ohm, so I can get 1 by 4. Okay, 1 by 4 second, 1 by 4 seconds. Okay, so you can write I, my I will be 6. Okay, e power minus t upon 1 by 4 is 40 ampere. Let me check first. It's correct. Okay, it is correct. 6 into 6 e power minus 40 ampere. Okay, so let me solve one more problem quickly. Okay, So I need to give an homework also. So what should I do? Okay. Okay. So this is question. Okay. Let me do one problem quickly. Okay. So you have this 24 ohm. Okay. You have this 6 ampere. Okay. And here is circuit which we are opening at t is equals to 0. Here you have 12 ohm. Okay. You have here 8 ohm resistance, and here you have 5 ohm resistance. Okay. And here you have inductor of say 2 Henry. Okay. And you're connecting this source like this. This is 2 Henry, 5 ohm, 12 ohm, 8 ohm, 6 ampere. Okay. Now solve the circuit, please. Find out what is I current flowing before time t is equals to 0. Okay. So calculate I at t less than 0 or I time before time t is equal to 0. Calculate. So once initially this is closed, so make it close. So once you make it close, what happens? Okay, my current goes here, current goes here, current comes here, current comes here. Okay, then current go here, and this, what happens to this? This becomes short. Okay, so now this circuit is short. Okay, so if this circuit is short, then what should I do? This circuit also becomes short, because now if it is short, okay, so this circuit, this 5 ohm also I should remove, because this will also become short, isn't it? Short होगा कि नहीं होगा? Okay, so if this becomes short, this whole becomes short. Okay, so I need this, I don't need this
5
one.
ohm कैसे शॉर्ट होगा?
भी ये 5 ohm है
5
ना,
ohm कैसे शॉर्ट होगा?
भी यहाँ से मैंने इसको शॉर्ट कर, ये शॉर्ट कर दिया. अब ये शॉर्ट है, ये शॉर्ट ही जो पूरा शॉर्ट हो गया. अब यहाँ पे कोई करंट आएगा तो करंट तो सीधे यहाँ चला जाएगा, यहाँ तो जाएगा ही नहीं. ओके, जो भी करंट आ रहा है, ये करंट यहाँ से जा रहा है, ये करंट तो यहाँ डिवाइड होगा ही नहीं, क्योंकि ये इसको लेसर पाथ मिल रहा है. भाई ये रेजिस्टेंस क्या है आपका? ये ऐसे तो कनेक्टेड है, शॉर्ट से तो कनेक्टेड है, शॉर्ट से कनेक्टेड है तो उसको हटा सकते हैं. ओके, सो यू कैन रिमूव दिस वन. ओके, सो दिस यू कैन राइट सिंपली 12 and 8. ओके, नाउ आई वांट करंट इन 12 ohm branch, because that branch current will come here. So I can again apply what current division. I have 3 branches, 24, 12 and 8. So I can write my current I12 in branch, I12 in branch. How can I write? How can I calculate?
सर
हम्म,
तो ये 5 ohm कैसा गया सर? कैन यू एक्सप्लेन?
अरे भाई उसमें नीचे से शॉर्ट है ना, उसको
Yes,
रिमूव कर
sir.
सकते हैं हम, उसको रिमूव कर सकते हैं हम लोग. ओके,
Yes, sir.
अब बताओ कि कैसे निकालूं मैं, कितना करंट आना चाहिए, निकाल के बताओ कितना आ रहा है. So can I divide current division law in 3 circuits? So कैसे करते हैं current division? If you have more circuits, okay? So all have a same voltage. फॉर्मूला क्या था?
total opposite resistance upon total resistance.
That was in two resistance. If there are more than two resistance, then if there are more than two resistance, then what is the formula? This was formula I R equivalent upon R1. Okay, if I want 12 ohm, is there any formula like this?
So I into R equivalent upon Rn, sir.
Rn. Okay.
Rn.
Rn है तो Rn मुझे 12 ohm चाहिए तो I can write 12 ohm here. Okay, 12 ohm. Suppose I want to apply this formula for two resistance. So this become R1 R2. This become R1 R2 upon R1 plus R2. So R1 cancel. This is correct formula. Okay, this is the correct formula. If more than two resistance are there, so I need to find what R equivalent. And so R equivalent will be what? 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so now 1 upon R1 is how much? 24. 1 by 24, 1 by 12, and 1 by 8. Okay, so select 24. Okay, this become 1, this become 2, this become 3. So this becomes 6 upon 24. So R equivalent become 24 by 6. Okay, that is 4 ohm. So I can write now I12 ohm is total current is 6 into R equivalent is 4. Now R1 is 12. So this is 1. This become 3. So this become 2 ampere. Okay, so this is my current I 2 ampere. Okay, so calculate R equivalent now. So this become 2 ampere. Now I have to remove the circuit from where? I need to remove the circuit from here. If I remove the circuit from here I have 5 ohm resistance now, and here I have an inductor of 2 Henry. Okay, so find now the R equivalent. Okay, 2 ampere I already know. Now you need to find R equivalent. So R equivalent कैसे निकलेगा? You need to open this one. Okay, so once you open this one, then
12 और 8 सीरीज में आ जाएंगे, 5 पैरेलल.
so if you put this one like this, okay, so current will divide. Okay, suppose assuming current here, current going here, and this current will go here. Okay, and this current will go here, and here also current division will take place. Sorry, I'm doing wrong. Okay, so if I am assuming current going from here, okay, so this current would come back from here. Okay, so current going here, 12 and right in series. Okay, and 5 is in parallel. So R equivalent, you can write 5. Okay, 5 plus 12
Parallel to
parallel to
20.
8. So 5 plus 12 into 8 upon 20. So just 4, 2, 4, 5.
So
Okay.
12 and 8 are in series, na sir? 12 and 8
Which
are in series.
12 they are not series ba, they are connected only one end. बीच में रेजिस्टेंस है ये, तो ये दोनों सीरीज में है, सेम करंट
12
फ्लो
और
करेगा.
8 na.
20 और 5 पैरेलल में.
अब फिर ये 5 भी पैरेलल में आ जाएगा. Okay, once I write this one, this will also come in parallel. Okay,
12 और 20 हो जाएगा ना, वो सीरीज में लगा.
12 और 8 series में होगा ना sir?
yes, which what you're saying?
So 12 and 8 are in series and 20 and then they are in parallel to 5.
12 and series. Okay, too. So what I'm doing, I'm writing like this. Okay, so this 12 series, 20, and this is 20. Like this, you're saying?
Yes, sir.
Yes sir.
Sure. Okay, calculate and tell me what is coming now. Okay, so this is it's correct. This is far 20, 25. Okay, this become 4 ohm R equivalent. Okay, so your time constant become L upon R. So this is 2
1 by
Henry
2.
upon 4, 1 by 2. Okay, so my I become what? I naught is 2 e power minus
Minus
2t
2.
ampere. Okay, so let me check the answer. Okay, so this is the answer. Now let me give some homework to you. Okay, Vt is equals to 56 e power minus 200 t volts. Okay, at t is equals to 0 time. Okay, it is equals to 8 e power minus 200 time t milliampere at t greater than 0 time. Okay, so this is given. So she say in a circuit. Okay, एक circuit दे रखा है आपको ये वाला, where you have been given R and C. Okay, so at a time t, voltage is V, which is given by this equation. It is also given. So he says number 1 A. Okay, find the value of R and C. Find the value of R and C. Okay, then number 2 they say calculate the time constant. Calculate the time constant tau. Okay, and number C they say time required voltage to drop, okay, half of its initial value, half of its initial value. This one question. Okay, I'm giving you one more problem. I'll leave it. Okay, this is so ये क्वेश्चन हो गया ना. Okay, so this is one homework. Okay, I'm giving you one more question. So you have been given a 15-volt battery plus minus 15 volt. Okay, then you have been given 2 kilo ohm resistance. Okay, and here circuit is open. Okay, at t is equals to 0 time, and you have been given a 4 kilo ohm resistance here. Okay, and you have a 3 millifarad. Okay, it's asking V naught. Find V naught at time t greater than 0. This is your homework. So कल हम खत्म कर देंगे we'll finish this network analysis tomorrow. Okay. And then we'll come our main part of syllabus. So any question from today's class? If there's no class question, okay, then thank you very much. Good night. I'm going to close this one.
Thank you, sir.
Thank you, sir.
Thank you.